Okay, good morning to all of you. In today's session of class 12 physics, we are going to do dipole. Thanks to chemistry and polar covalent compounds, we are already introduced to the concept of dipole. So thanks to chemistry and thanks to polar covalent molecules, you know that a dipole is basically a combination of two equal and opposite charges placed very close to each other. So suppose in a dipole, the negative charge is minus q, positive charge is q, and the separation between them is d. Okay, the negative is minus q, positive is q, and the separation between them is d. So every dipole has got a vector associated with it. Every dipole has got a vector associated with it. That vector is called dipole moment. So dipole moment P vector is magnitude of charge into the distance, and this vector will point from negative to positive charge. So you multiply the magnitude of either charge into the distance, and the distance will be taken from minus q to plus q, and obviously the SI unit is coulomb meter. You are aware, thanks to chemistry, that there is another unit that is dBi. But we are not really doing polar molecules now, so we don't have to discuss anything beyond coulomb meter. Now in dipole, there are two very important formulas. Number one is torque on a dipole. Torque on a dipole in a uniform field. Okay, torque on a dipole in a uniform field. This is number one. So, suppose there is a dipole. Suppose there is a dipole, and the positive charge is here, the negative charge is here, and the line joining the negative and positive charge, that straight line is called the axis of the dipole. An axis of the dipole makes an angle theta with the electric field. So this is the electric field, the axis makes an angle theta with the electric field, and the distance between the two charges is d, right? So the force acting on positive charge will be QE, it will be to the right, and the force acting on negative charge will be minus QE, it will be to the left. And due to these two charges, the torque, it will be QE, that is the force, into the distance, the distance between them. Now the thing is that the distance between them is d, so therefore we can say that this will be d by 2 sine theta, and this will also be d by 2 sine theta. So Q into E, right, and then the distance between them, suppose this is O, this is A, and this is B. So it will be OA cross QE minus OB cross QE. So this will be the torque, because you remember the formula of torque is R cross F. So OA cross QE minus OB cross QE. So that means so ultimately you will get OA plus BO cross QE. Okay, OA plus BO cross QE. So this will become BA cross QE. Right? It will become BA cross QE. So BA is the dipole moment vector P. So therefore it will become BA is actually the distance from negative to positive, and that distance into charge is dipole moment. So therefore the torque on a dipole moment in a uniform field, the formula is dipole moment vector P cross E. So let's just recap whatever theory I have told you. There is a combination of negative and positive charge placed close to each other. That combination is called a dipole. The distance between the two charges is d. So dipole moment vector P is q into d. It is a vector pointing from negative to positive charge. SI unit is coulomb meter. In chemistry we use dy, but we don't have to bother about dy right now. Torque on a dipole in a uniform field. Suppose there is a uniform field E and you have placed a dipole in that field. So the force on Q will be Q into E vector. The force on minus Q will be minus Q into E vector. It will point to the left. And O is the center of the dipole. The line joining the charges is the axis of the dipole. Axis makes an angle theta with the field. So this is d by 2. This is d by 2 sine theta. Okay, and this d by 2, this d by 2 sine theta again. And torque, you know, is R cross F. So for the positive charge, OA cross QE, and for the negative charge, minus OB cross QE. So OA plus BO cross QE, so BA cross QE. But BA is the vector joining the negative to positive charge. That vector into charge is dipole moment. So the torque on a dipole in a uniform field, the formula is P cross E, right? Okay, then the next formula is potential energy of a dipole. So the work done in rotating the dipole against an external torque is dW is minus torque d theta. So the change in potential energy is negative of work done because electrostatic force is conservative. So du is torque d theta. So you know torque is P cross E. So torque d theta will be Pe sin theta d theta. Now, if you rotate the dipole from an initial angle of 90 to a final angle of theta, this is the change in potential energy. And conventionally, we take 90-degree potential energy as 0. This one, you know that integral sin theta will be minus cos theta. So finally, we are getting the formula that potential energy is minus P dot E, which basically minus P cos theta, which comes to minus P dot E. So these are the two formulas in today's class: torque on a dipole and potential energy of a dipole. So I am giving you the homework now. the first homework question, there are two charges 5 microcoulomb and minus 5 microcoulomb kept 1 millimeter apart. What is the dipole moment? That is number 1. There are two charges 0.25 microcoulomb kept at 0, minus 15 and minus 0.25 microcoulomb kept at 0, 15. So you have to find the dipole moment of this system. You have to find the dipole moment of this system. This is homework question number 2. Question number 3. Question number 3, there is a dipole minus 1 microcoulomb and plus 1 microcoulomb which makes an angle 30 degree with an electric field of 10 to the power 5 Newton per coulomb. So for this situation, what is the dipole moment vector and what is the torque? This is number 3. So these are the 3 homework questions. There is no homework session today. You can submit the homework by 9 p.m. tomorrow, that is Saturday. That will be all. Bye all of you.